So by the fourth week of a musculoskeletal anatomy course, most students are familiar with the shoulder, which has about 14 muscles they're probably going to teach you, and the arm, which has 5 or 6. So you might have encountered 20 muscles by the end of week 3, and you might be feeling a little bit overwhelmed by that. And then we get to week 4 and we teach you the forearm and the hand, usually together. And the forearm has 17 muscles and the hand has 18. So you're about to get overwhelmed. And traditionally the forearm muscles are the ones that students really just lose their brain over because there's so many of them. It's very hard to distinguish between the muscles when you're looking at a prosected specimen. There's a whole heap of names and there's a lot to remember, and by this stage students are usually getting pretty overwhelmed. So what we're going to do is try to just give you a little framework here that will help you understand the forearm muscles. There are 17 muscles in the forearm, but we're not going to worry about the pronators and the supinators, so that gets rid of 3. We're going to concentrate on 14 muscles here. These muscles are the ones that run down the length of the forearm. All but one of them actually cross the wrist joint and are extrinsic muscles of the wrist or of the digits. So they're either wrist flexors and extensors, or they're digital flexors and extensors. The one muscle that doesn't cross the wrist is the one we're going to start with, though. It's called brachioradialis, and it goes from the brachium, so from the humerus, to the radius. It's a flexor of the elbow when the hand is half pronated, so i.e. when the hand is in a functional position. If you think about all the times you pick up a cup of coffee or a pencil or even a bucket of water or something like that, you're using your hand in a functional position. Later on, if you ever become a surgeon and you need to, or treating somebody who's broken a wrist and you need to immobilize the wrist, you always would immobilize it in that semi-pronated position, that functional position, because that's the most useful position to have your hands in. Brachioradialis is a flexor of the hand, the flexor of the elbow when the hand is in that position, that functional position. And so if you try doing a karate chop, which is hand in that functional position, and then tensing the elbow, you'll see brachioradialis kind of coming up at you through your skin towards you. It's bowstringing, okay? It's cutting the corner of your elbow because it's the muscle of the forearm that attaches the highest up the humerus. That's really useful because it means when you've got a prosected specimen in front of you, you just look for the muscle that goes the furthest up the humerus, and that's brachioradialis. You can identify it without making a mistake. Just check that the insertion is on the radius, not crossing the wrist, and you've identified your first muscle. The great thing about that is that all of the muscles in front of brachioradialis are flexors, and all of the muscles behind brachioradialis are extensors. So it's a really good landmark to find. After we've done that, we're going to divide the muscles into 3 basic functional groups. These green ones here are kind of on the sort of 4 corners of the wrist joint. And they're going to be the muscles that move the carpus. So they're all going to be something, carpi, something. And we're going to have these ones in red here, which are going to be the superficial flexors and extensors to the digits. And then in blue, we're going to have the deep flexors and extensors to the digits. So those are our 3 functional groups. If you're looking at the green ones, if you move the 2 flexor ones together, you will flex the wrist. Move the 2 extensor ones together, you'll extend. If you move the 2 ulnar side ones together, you'll do ulnar deviation of the wrist. If you move the 2 or the 3 radial side ones together, you will radially deviate the wrist. If you move them all together, or if you tense them all together, you will stabilize the wrist. That's the sort of thing you do when you're doing your push-ups, or you're making a fist for punching or something like that. So we can call these green muscles wrist stabilizers. Each one's got a name. What are we going to name them? Well, they're always going to be named after their function and their position. So this one here, we're going to call flexor carpi radialis. And then this one here is going to be flexor carpi ulnaris. And that's going to be extensor carpi ulnaris. And that is going to be extensor carpi radialis. There we go. Nice and logical. We just have to remember there's 2 of those, brevis and longus, short and long. We've named 6 muscles, and we have not had to memorize anything yet. Okay, so those are the ones to the carpus. Now the red ones are going to be our superficial flexors and extensors to the digits. If we look at this one up here, this is a flexor to the digits. It's superficial, so we're going to call it flexor digitorum superficialis. And then if we look at this one down here, this is going to be flexor digitorum profundus, because it's deep, profound, deep. Come to the radial side, then the digit on the radial side of the hand is the thumb. So this is going to be our deep flexor of the thumb. It's actually also our longest flexor to the thumb, so that's flexor pollicus longus. And we mustn't forget this little one up here, which most of you will have, just goes to the palmar aponeurosis, so that's palmaris longus. On the extensor side, we've got the extensor digitorum, and the belly of that goes to the little finger gets its own name, so that's extensor digiti minimi. And then with the deep extensors, well, the three of them go to the thumb. We've got an abductor to the thumb and two extensors. The abductor to the thumb is the long one, because the short abductor is an intrinsic muscle. We'll meet that later. But the two extensors, there's the long and the short, so extensor pollicus brevis and extensor pollicus longus. The tendons from those three muscles come from deep, so the muscles originate from the back of the radius and the interosseous membrane. The tendons come from deep and they wrap around the top of extensor carpi radialis. Usually abductor pollicus longus and extensor pollicus brevis tendons are close together, and there's a space just behind the thumb. Then you get the extensor pollicus longus tendon, and that space in between them is your anatomical snuff box where you can get a radial pulse. Okay, that just leaves us one muscle. This one on this side here, in a baboon or something like that, this is going to be the deep extensor of the digits. So extensor digitorum profundus would be a good name. In humans though, one of the things that we've done is we've really emphasized the mobility of our index finger relative to the others. So we have amazing independent control of our index finger. And that allows us to do this signature human movement, which is the precision grip. And precision grips are really useful if you're doing delicate tool making and all that sort of stuff, which is obviously a signature part of human evolution. But the trait that allows the precision grip is not necessarily opposition of the thumb, because all primates can oppose their thumb. It's the fact that the index finger can be moved independently of the other fingers so that it can form this precise opposition to the thumb. So what was extensor digitorum profundus in other primates is now extensor indicus in humans. It's one of the sort of signature human muscles. Understanding that evolutionary history helps explain why a muscle going to a digit that is on the radial side of the hand actually originates from the ulnar side of the forearm. If you're ever trying to remember which epicondyle of the humerus these flexors, the superficial flexors and the superficial extensors come from, you just have to think of the hand in the functional position. In the functional position, so hands down by the side, as if you're going to pick up a bucket of water. The flexors are all on the medial side and the extensors are all on the lateral side, and that means, of course, that the flexors all come from the medial epicondyle and the extensors all come from the lateral epicondyle. And that is 14 of the muscles of the forearm.